Welcome to Factorio Engineering. My name is Nilaus, and today we're going to talk about the most fantastic mod, Logistic Train Network. The way I'm going to structure this engineering session is that I'll start by explaining the purpose and the brilliancy of the Logistic Train Network mod. Then I'm going to build a simple setup, and I'm just going to make it more robust and more advanced until at the end we have basically the components we need in order for you and me to implement Logistic Train Network in your own base. I'm making this video because my Megabase campaign, Modular Megabase, really needs a Logistic Train Network in order to continue to scale. Now, as promised, let's start by explaining the purpose of the mod. The mod is basically transforming your train network into a logistics network, hence the name Logistic Train Network. Now, what this means is that you will create provider stations and you will create requester stations, and train schedules will then be generated automatically by the mod between providers and requesters, thereby balancing out many requesters and many providers. Because if you have one iron location or iron provider and one iron requester, then it's easy to set up a train schedule going back and forth. But if you have 5 iron providers and 7 iron requesters, then it becomes a lot less easy to figure out how to balance. All right, this one gets 2, but this one gets 1, and now that ran out, and what am I going to do then? And it'll just be a hell of a lot of maintenance to keep some kind of balance. And this is where the Logistics Train Network comes in, because it will monitor all that is provided and monitor all that is requested. Then it will generate schedules matching supply and demand. Brilliant, huh? I think it's brilliant. I love working with it. Every time I build train networks without Logistics Train Network, I get a bit annoyed because there's no reason to do this kind of simple thing. This is very much in tune with the idea of Factorio. So I built this little test setup, which basically consists of 3 stations: a depot station over here, a loading station over here, and an unloading station down here. Now let's start by building the stations in a very simple setup so I can showcase how this mod works. The first thing we need to do is first thing I need to show is the difference. There is one new building in this mod. This is a normal train stop. It consists of just the train stop. Then we have a logistics train stop here. This consists of the normal train stop plus a combinator here behind it that is used for... Actually, why did I do it like that? I could make it a lot easier to see if I put it on this side. So there's a constant combinator that says logistic train stop output. So this is what the network tells us, or tells the stop. This one is the input, the little lamp, and that is what we tell the stop or the train network. And that's how it works. So basically, if we want to tell the network something, we put it in a light bulb. If we want to read something from the network, we take it from the combinator. So I'm going to take a combinator here. I'm going to put in a signal. One thing I should mention about this mod, it's not a simple mod. And you need to play around with your with circuit network. So if you're not comfortable with that, well, you follow carefully or and try it, or just say this may not be for me. So I need this signal. Stop is depot, because that informs, and then that's where it goes here. This one informs here. There you are. This informs that this is now a depot. And when I send a train there, it changes to blue, because that just indicates that it is a stop and there's someone waiting at the stop. I'll probably also read this this network. Now, at this point, you can, for example, see that this one, the output, tells us something about the trains at this location. I don't know why, but for some reason, the number of wagons is multiplied by 3. If I put one more on, and oh, what? Why is there nothing there? Oh, like that. Then it's 14. I have no idea how that works. I'm sure there's a logic to it, but it is beyond me what logic is. Okay, so this one means now we have a train. This is basically a roboport with a robot waiting in it. Now let's move up here. Here we have 4,000 iron wired up here. And what we need to do is take the content and provide it into the network. That means we take a red wire from here, up here, and into the network. Brilliant. It doesn't do anything because now we just have told the network there is provided 4,000. It would actually be nice if there was sort of like a UI to see how much is provided to the network and how much is requested from the network. But don't think that exists. So right now we have a depot, basically the equivalent of a roboport with a robot in it, and a request or a provider chest, but not a requester chest. So this one is where we built the requester. The way this is done in an absolute really simple way is to say how much iron we want as a negative number, and then simply sending this into the network. You will see, boom, creating delivery from LTN load to LTN unload, 4,000 iron plate. Brilliant. So it goes up here, loads my train, and goes down here. So at this point you're like, all right, that's brilliant. I'll do this. This is really the key trick or the key challenge of this mod, is that a lot of people can get to this point, but there are a number of things that will inevitably go wrong if you stop at this point. Because first thing, at this point now, I do have some content. I also have something on the train still, but I'm still requesting 4,000. It's just constantly requesting 4,000. So that's impractical. And this is not saying how much each train will get. It just says, try to make sure that I have 4,000. Except now first it says nothing. But if we look up here, this is because it has 700, 800, 900. Once it goes above 1,000, it will generate a train schedule. Boom. Generate train schedule. And it goes in. Now you will see one of the key problems with the LTN if you don't make a contingency for it, because the train schedule that automatically generated is it goes to load until it has the amount requested and 2 seconds of inactivity or 120 seconds have passed. Now this and is a correct way of doing it, but it means, for example, in this case, it will not stop loading when it reaches the 1057 that it was supposed to, because it never reaches this 2 seconds of inactivity until the train is completely full. And that is something we have to fix. But first, we're going to fix this part here. This part, which basically says, and I keep running on trains. I wonder if I get run over. Now, here we have how much is in. If I, for example, just flip this so it would stop. Let's just let it run for a bit. Now it goes idle for 2 seconds and it goes down here and starts unloading. It will now fill up. You can see here, this is being filled up. Now, this is a positive number. This is putting in a negative number. And actually, I think I'll just remove this. I think I'd rather run it by this one so I can see the content. Now, what if I did from here, from here. Now you can see this is how much is being requested. Minus 162. And because I'm basically saying you're requesting 4,000 except for the almost 4,000 I have here. Hence, no new schedules are generated. When I flip this around, it will start moving up. And by default is set to at the moment when it's okay. That was actually quite a little omission there. When the provider here is 1,000, then it will generate a schedule. It will generate a schedule when it can pick up 1,000 and deliver 1,000. So this one also has to be okay. This one is enough, and once this one hits 1,000, then it goes in. So the next part I really need to fix is I want to make sure that this stops loading once it has received what it needs. Now I can take from this station. Now I'm wiring this station with a green wire to this one. So let's look at the station. Station must read train content and look at the green. So the green here is saying 2.4 inbound on the train. And of course my neighbor decides to use a power drill at right at this moment. So sorry for the background noise. And you can see here. Now shut up. This is how much is requested. This comes from the outbound of the train stop, 1,000. And this is how much is on the train. So what if I just walk past it? Now what if I start by doing something different? How about I use these instead? These are stack filter inserter, and then I set the filter because then I can control when they will load. Now what if the station says give me 1,000 and the train content is 800? Then it would be nice if it says keep going, but as soon as the train content is equal to the requested, this should be 0 or a negative number, and then that removes. So now it will not load. That means we get here, we get a 1,000. What I can do and what I will do here, and do I not have this? Oh no, I don't have any. This is horrible. And I am going to get some here, and also some green. See, the problem is that what I'm missing is here. Good. I got a few of them. That's what I need. All right, that was a bit of a intermezzo here. Run in front, great, because that's the safe thing to do. Now, what if we take the content of the train coming from here up to that one on the green wire, the content of the train, and take anything that goes in and multiply it by -1, and the content going out. Now I can then take, see, that's of course still 0. But what if I combine the output here with how much is being requested? That means they will start loading, and you can see how it works. Boom. It stops because the content of the train was equal to the requested amount. And this way I have now made, okay, actually I want it a bit closer. I don't want it all the way up there. Actually, you could say it. The best way to do this is like this, and now it goes into, it creates another delivery, and I'm going to remove this one and wire it up differently. So from here in, from here to outbound, oh come on, outbound to that one. All right, let's see. This one is, you can see it goes down. This is requesting 2,900, and here we have, and it stops, and it's 2,900 as requested. Great. So I can see this working. Now I would like to have the same capability down here so that it basically only unloads what is on the train. It is not as necessary, but I think sort of for good measure. Here, set filter. It's important to remember the set filter, otherwise it doesn't work. Now in this case, it's quite simple because I just need it from this train stop out, and remember to take this one and say read train content. There we go. So the train content is boom, 0, and then it stops. As long as this reaches a negative number, then these filters will not be set. Good. So so now we've made it robust, but it is not as advanced as I like it, because imagine your base and you have trains with iron running around with 1700 plates. That's no good. No good at all. So why don't we say, I don't want a train schedule to go out unless it it can pick up at least 3,000. At least 2,000, right? So at least 2,000 is what I need here. So that we can do that by setting up another condition here. This is another of the special icons here. It says, do not provide or only provide it when it's more than 2,000. We take the wire. This is data that goes in like this. So this goes into the lamp. That means it goes into the network. So at this point, we should see that no new schedule is being generated until this number here reaches 2,000. Let's see, it goes up there and nope, nothing is found because it says there is a demand, but there is no supply because this one doesn't supply until it reaches 2,000. And now we can do sort of the equivalent over here on the requester side. Since we already have one, we can just put it in here. This one we can say on the requester side, how about we only request when we can request at least 2,500. So from now on, I want at least 2,500. Otherwise, I will not generate a train schedule in. And let's see how this goes. So that means now it must be requiring 2,000. Oops, here you can say this one actually requires 2,500. It requires almost 3,000 at this point, but it needs two conditions to be fulfilled. The fact that I need at least 2,500, and I can pick up at least 2,000. And that's actually a pretty brilliant way of controlling this, because for example, for iron, you don't want to have the provider station provide until you have a full train, because then you basically say, all right, when the train is full, you can go. And again, see 2,100. So if I'm running in front of trains, it is not safe. I'm gonna let it go. So in this case now I'm bouncing this one up to 3,000. So we are going down here. This one's still 2,500. So once this one is easily requesting 2,500. So at this point it is now requesting, but it is not providing yet. See, nothing is being provided until this one reaches 3,000. So we just have to patiently wait until it reaches 3,000. This one has met its condition and therefore it's sending a request signal into the network. This one has not reached it yet, so then is still waiting. No train schedules generated. As soon as it's 3.0, boom, it should go. 3,009. And there you have it. This is basically it. So what you can do now is you can say, I have my iron 1, 2, 3, 4, 5. They're all providing. Every time it can fill up a train, then doesn't matter how big your train is. Every time it can fill up a train, it provides it to the network. And then you have your consumption location where every time it has storage for a full train full, it sends out the signal. And based on this, you can basically have the train schedule just generate itself. The one thing that should remind you is you will need a lot of train schedules, depots, because the depots are decoupled. This depot doesn't belong to these two. This depot belongs to all of the network, which means that you're really, you maybe just need to build a big area where you build lots and lots of depots. And then once that's done, you have 20 trains there, or 30 or 40 or 50, 100, depending on how big your base is. Then you can start converting the requester stops and provider stops into logistics train network stops. There you have another train schedule generated. The one thing is also important is, in the beginning, you're going to be really happy with these comments because it just gives you a sense of joy to see things generated. I recommend keeping this enabled for a long time, but once let's see if it actually is a mod look option, mod settings, LTN, message level, notification, only errors and warnings. There. That is important to be able to know this, because it's going to drive you crazy with all the beeping. At least it's going to drive my viewers crazy with all the beeping. But keep it along for a while until you feel really confident that things are working, and then switch it over to only warnings. My recommendation is also using the depot as the fuel stop. So you can maybe make 20 different depots next to each other, and then make the 21st station a fueling station that then ensures that everything is fueled. That's a pretty good way, I find, to have everything operational. It's not likely that it's the same train going in and out, and therefore it doesn't get time to fuel, especially not when you're using the good fuel that lasts forever, the nuclear fuel that lasts forever, pretty much. Okay, so this is Logistics Train Network. I will start implementing into my Modular Megabase, and this will be by episode 40. So if you're interested to see how this is being used in a bigger scope than just this very small little thing, then you should drop by episode 40 and watch from there if you're not already watching it. So with that, thank you very much for joining. I hope you found this interesting and relevant, and also sufficiently structured, despite the fact that it is not really a tutorial. And hope that I'll be seeing you in one of my other campaigns or another engineering session. Thank you for joining. See you next time. Bye.